Now, let's apply the law of conservation of momentum in solving problems. So for our first example problem, a freight train is being assembled in a switching yard. Car 1, this red one, has a mass of 65 kilograms and moves at a velocity of 0.80 meter per second. And car 2, this blue one, with a mass of 92 kilograms and a velocity of 1.3 meter per second, overtakes car 1 and coupled to it. Neglecting friction, find the common velocity or the final velocity of the cars after they become coupled. So in this our example, we have a completely inelastic collision. So our given, we have mass 1 of 65,000 kilograms. Mass 2 of 92,000 kilograms. Initial velocity of object 1 of 0.8 meter per second. And the initial velocity of object 2 is 1.3 meter per second. So we're looking for the final velocity of the coupled train. So applying the law of conservation of momentum, that the sum or the total final momentum of two colliding objects is equal to its initial momentum. And let's express this with mass and velocity. So we have mass 1 and the final velocity 1 plus mass 2 times the final velocity of 2 is equal to the mass 1 and initial velocity and mass 2 times its initial velocity. So as given in the problem, after the collision, the two train moves in one velocity. Therefore, the final velocity 1 and final velocity 2 is equal to final velocity or equal. Thus, we have mass 1 plus the mass 2 times with the final velocity will be equal with m1 times to its initial velocity plus mass 2 times to its initial velocity. Therefore, we can solve now for the final velocity of the coupled train. With this expression. So substituting the value, we have 65,000 kilograms times 0.8 meter per second plus 92,000 times 1.3 kilograms divided by the sum of two masses. Therefore, our final velocity is equal to 1.1 meter per second. This is positive value. Okay. So now let's proceed with our second problem. Okay, so for our second problem, starting from rest, we have two skaters push off against each other on smooth level ice, where friction is negligible. As a figure shows, one is a woman with a mass of 54 kilograms, and the man is 88 kilograms. Part B of the drawing shows that the woman moves away with a velocity of 22.5 meters per second. So find the record velocity Bf2 of the man. So our given, we have mass 1 of 54 kilogram, which is the mass of the girl. And the mass of the boy is 88 kilogram. And they started at rest. Therefore, the initial velocity 1 and initial velocity 2 is equal to 0. And the final velocity of the girl is equal to 2.5 after they push each other. So we're looking for the recoil velocity of the man, or the final velocity of the man after they push up against each other. Okay, so using the law of conservation of momentum, you know that the final momentum, the sum or the total final momentum is equal to the total initial momentum. So in this case, our initial momentum is equal to 0. Why? Because we have a 0 velocity. Again, our definition for momentum is mass or object in motion. Therefore, if our object is at rest or stationary position and not moving, therefore it has a 0 momentum. Okay, so let's express this expression with mass and velocity. Therefore, we have mass 1 times to its final velocity plus mass 2 times to its initial the mass of final mass of object 2 is equal to 0. And to solve for the recoil velocity of the man, it is equal to negative product of mass 1 times its velocity, final velocity divided by mass 2. Substituting the value, we have now negative 54 kilograms times the final velocity of the girl, which is 2.5 meters per second, divided by the mass of the man, which is 88 kilograms. Therefore, our final answer, or the recoil velocity of the man, is negative 1.5 meter per second. Okay, so now let's test your understanding. Try to solve this problem and write your answer in your LMS.